All right, we're going to talk about, well, visual quality improvement when it comes to graphics on the Quest 3. Now, one hint for this, how it can be improved, is actually on this post by Visual Robot, the developer of Red Matter 2. Now, this was posted on October 2nd, 2023 by the developer on Twitter, X. And basically, they mentioned the different improvements, enhancements you can expect both on the Quest 2 and the Quest 3. So we can see with the Quest 2 we have dynamic resolution enhancement. Quest 2 now supports dynamic resolution, enhancing visual clarity. Now I'm going to talk about each one separately so we can understand really the differences. So basically, if you look at the Quest 3 enhancement, you can see that the screen resolution upgrade, dynamic resolution significantly increased. The upper limit increased significantly from the previous fix that was on the Quest 2. Now, for those of you who are new to this term, dynamic resolution is a technique that dynamically adjusts the rendering resolution of a game or application in order to maintain a consistent frame rate. This is done by monitoring the frame rate and adjusting the resolution up or down as needed. For example, if the game or application start at low resolution, the frame rate is kind of monitored. If the frame rate is above the targeted frame rate, the resolution is increased. If the frame rate is below the target frame rate, the resolution is decreased. And you can repeat again until the frame rate is consistently at the target frame rate. Usually you can expect target frame rate to be around 60 FPS, but again, it can be higher. Again, it depends on the targeted frame rate for a particular app and game, just higher or lower depending on the device and the game or application. Now, again, if developers are using the feature because this is as a limit of 1440 by 1584 per eye for the Quest 2, with the Quest 3, because it's higher now by 30%, this means that almost all apps and games will just look sharper and clearer by default. This is because the Quest 3 automatically renders at higher resolution in almost all apps and games. Now, we also need to take into consideration that according to Meta, using the new pancake lenses, we can expect around 25% improved clarity in the center and 50% improved around the edges. So that also supposed to improve the overall viewing experience. In fact, on the trailer that they posted, the developer for the Quest 2, when Red Matter 2 was released, they're actually mentioning lots of those improvements. And again, this was just for the Quest 2. For example, particle reflection, multiple point lights, volumetric lighting cones, optimized metahumans, high quality glass, sphere soft shadows, ray trace line reflections, ray trace quad reflections, glass refraction, parallax corrector reflection, and filmic tone mapper. So even again, with the Quest 2, they were able to really bump the visual quality for Red Matter 2. And there are more enhancements like 4K textures leveraging Quest 3's enhanced memory. Textures have been upgraded to console quality, boasting up to 60 times increase in pixel count. And again, alongside the anisotropic filtering, we're going to have really enhanced sharpness of textures. Now, for those of you who do not understand these technical terms, anisotropic filtering is a technique used to improve the quality of textures in video games. It works by taking multiple samples of a texture and blending them together to create a more realistic and detailed appearance. It's especially important for textures that are viewed at an angle, such as the ground in first-person shooters, for example, or the walls in a dungeon. Without anisotropic filtering, this texture can appear blurry or pixelated. And of course, if the higher this level of anisotropy, the better the texture will look, but it will also require more processing power from the GPU. But now that the Quest 3 have a more powerful GPU, they were able to increase this as well and improve the quality. So overall, the result of increasing this will include sharper textures, more realistic and detailed textures, reducing blurring and pixelation, and overall improve immersion. This is, for example, on Wikipedia. You can see the trilinear filtering in anisotropic on the right side for comparison. Nice, you can see kind of the difference. Again, not in-game, just an example from Wikipedia. And you can see that when viewing from an angle, it looks sharper with the anisotropic filtering compared to trilinear. Now, next thing is dynamic shadows. You can see spotlights now cast dynamic shadows, adding a layer of realism to the scene. Now, dynamic shadows are shadows that are calculated in real time based on the position of the light source and the objects in the scene. This is a contrast to static shadows, which are pre-computed and don't change as the scene changes. So dynamic shadows are more realistic than the static shadows because they accurately reflect the position of the light source in the objects in the scene. For example, if you move a light source in the scene with dynamic shadows, the shadows will move accordingly. If you block a light source with an object, the object will cast a shadow. So dynamic shadows are more computationally expensive to render than static shadows, but they can significantly improve the realism and immersion of a game. Now, the next thing is shadow filtering. Now, basically this means that this particular shadow filtering technique is used to improve the quality shadows in video games. It works by taking multiple samples of the shadows and blending them together to create a more realistic and detailed appearance. So PCF stands for percentage close filtering. It's a common shadow filtering technique that works by comparing the depth of the shadow to the depth of the object in the scene. The closer the shadow is to the object, the darker it will be. The further away the shadow is from the object, the lighter it will be. So this PCF 5 is a specific type of PCF filtering that takes 5 samples of the shadow and blends them together. This results in a softer and more lifelike shadows. Shadow filtering is a technique used to improve appearance of shadows in video games. It works by smoothing out the edges of shadows and reducing aliasing. In the context of Quest 3 Red Matter 2 game, this shadow filtering will make the game look more realistic by producing softer and more lifelike shadows. And again, to give you an example, imagine you're looking at the shadow on a wall. The edges of the shadows may be jagged and aliased. This is because the shadow is made up of pixels, of course. And the edges of the pixels are not smooth. But with this shadow filtering, it will work by smoothing out the edges of the shadow and reducing aliasing. This is done by taking multiple samples of the shadows and blending them together. And again, the result is softer and more lifelike shadow. Again, the result will be more lifelike results of how you expect shadow to appear, and of course higher immersion and overall just better visual experience. Alright, the next thing is mesh level of details improvement. Basically mesh LOD, this is currently short improvements. In the context of the Quest 3 and Red Matter 2 games we are talking about here, refers to an improvements in the way the game's 3D models are rendered. LOD stands for level of detail and is a technique used to reduce the complexity of 3D models as they move further away from the player. And by the way, if you wondered, Red Matter 2 runs on a heavily modified version of Unreal Engine. And by the way, speaking of which, I'm going to give you an example. This is on PlayStation 5 running Unreal Engine 5. And basically, I was able to toy around, but basically uses some kind of technique to reduce the level of details of 3D models when I get further away from the 3D object, and then get more details and resolve more details as I get closer. So again, this is just kind of to explain things. And again, for example, let's give you an example. If there's a tree in a video game and the tree is close to the player, the game will render it using a high LOD model. This will result in a detailed, realistic looking tree. If the tree is further away from the player, the game will render it using the lower LOD model. This will result in a less detailed and realistic looking tree. But it will also require less processing power to render as well. So mesh LOD improvements work by reducing the difference between the high LOD model and the low LOD model. This makes the transition between LOD less jarring and reduces LOD popping. So again, overall, mesh LOD improvements in Red Matter 2 will make the game look more visually appealing and reduce immersion breaking artifacts such as LOD popping. Now, I don't know the exact technique they actually use there compared to what we have in Unreal Engine 5, but again, basically it will supposed to give you again what I mentioned, more realistic looking games, textures, and 3D models will appear sharper the closer you are to a certain object. Whether you get far from them, it will just reduce it, and of course it's supposed to also improve the overall performance of the game compared to if you just use very high quality asset and you spread them throughout and there's no way to actually reduce their quality. This is, by the way, why Unreal Engine can render games that look so realistic from the cinematic quality, and basically behind the scene just deals with all the complexity, so developers can actually just put very high quality models and let the engine just do all the rest. But again, as I mentioned, I don't know the exact technical aspect of the game, how they did it, and I would compare to modern game engines. But again, this is a good feature to have in a game. And the last thing is frame rate adaptability. So we're going to see during combat, Quest 3 will dynamically adjust frame rate from 72 FPS to 90 FPS. So again, it depends on the amount of action happening, and to stabilize probably the frame rate, this will be happen dynamically during the game. So yeah, so I hope you enjoyed this one and going all the different features and understanding what the Quest 3 enables in practice for developers in games that we can actually play with the Quest 3 compared to the Quest 2. And of course it will be different, depends on the game we are playing. This is just one example, but there is reason to get excited seeing the developers can really take good use of the more powerful computing power of the Quest 3 compared to a previous generation. If you like this video, consider maybe leaving a like and subscribe to my channel. More coming. I hope you enjoy this one. I'll see you in the next video. Cheers.